Hello, welcome to Chapter 4, Homework Questions 69 through 74. Question 69. Eddie is arguing with Tana about the probability of flipping 3 coins. They decided to flip a penny, a nickel, and a dime. Part A. Which would be better for determining the sample space, a tree diagram or an area model? So for this example, probably a tree diagram would be better. An area model would require kind of a third dimension because you're dealing with 3 different things there. Part B. Make a sample space that shows all the possible outcomes. How many outcomes are there? So if we are going to do a tree diagram, we start with our first coin, and when we flip it, it's either going to be heads or tails. Those are the 2 options. And then once you flip your next coin, from there, you're going to have another 2 options, heads or tails, and that's going to continue to happen with the third coin. And then on the bottom, the same thing's going to happen if you flip a tails first. You're going to have 2 options after that, either heads or tails. And then once again, 2 more options on that third coin, heads or tails. So there's a total of, how many outcomes are there? There's a total of 8 outcomes. Part C, find the probability of each of the following events occurring. Be sure to show your thinking clearly. So to show part of this, I went ahead and showed you the outcomes based on what could have possibly been flipped with the 3 coins. So that might help us answer this probability a little bit easier. On the first one, 3 heads. So when you look at these, all of these, there's 8 possible outcomes, are all the same likelihood to happen. They'd all represent 1/8. But for 3 heads, there's only, if you look at this, there's only, out of the 8, there's only 1 that have all heads. So therefore, for 3 heads to occur, that's going to represent 1 out of 8 possibilities. Alright, and number 2, 1 head and 2 tails. So 1 head and 2 tails. I'm trying to highlight here. So 1 head and 2 tails. So there's 1 right there. 1 head and 2 tails. 1 head and 2 tails. So there's 3 out of 8 that could occur. Based on those 8 outcomes, 3 of them have 1 head and 2 tails. So that would be 3 out of 8. Number 3, at least 1 tail. So at least 1. There's 1. There's at least 1. So you can have 2. You can have 3. So there's only 1 that actually doesn't have a tail in it, and that's when you get head, all the way across. So that would be 7 out of 8 possibilities. And then exactly 2 tails. So 1, 2, 3, and that's it. So it looks like there are 3 possibilities where you have exactly 2 tails out of 8 total outcomes. Part D, which is more likely, flipping at least 2 heads or at least 2 tails? Well, right now I have 2 tails already marked. It says at least, so I could actually include the 3 tails. That would be 4, and then I'll highlight the ones that have at least 2 heads. So that would be that one, that one, that one, and that one, which is really what was remaining. And so it looks like they are equally likely to happen. The probability for both of them would be 50%. And then part E. How would the probabilities change if Tana found out that Eddie was using weighted coins that were not fair? So that the probability of getting heads for each coin was 4/5 instead of 1/2. Would this change the sample space? Recalculate the probabilities in part C based on the new information. Alright, so the first question is, would this change the sample space? The sample space isn't going to change. The same things are going to occur, but we need to recalculate the probabilities. So for example, on I, it wants 3 heads. That would be 4/5, 4/5, and 4/5 instead of 1/2 times 1/2 times 1/2. So now 4/5 times itself 3 times, or we'll just write it this way, would be 64 over 125. So that would be your new probability, which is completely different than what we had before. Last time we had 1/8. Now we've gone from 1/8 to over 50% of it, the probability being over 50%. Number 2, 1 head and 2 tails. So let's see, 1 head and 2 tails. Last time that was 3/8. So 1 head and 2 tails would be this one, and this one. 1 head and 2 tails. And so I went back through and kind of remarked some of these. So if we want this one, we'd have 4/5 times 1/5, and then tails would be 1/5 here. So we'd have to multiply those. And then we got 4/5. I should have marked the rest of these. Anyways, I'll finish marking them, but then we need to multiply and then add those together. And so no matter what, you have 2 tails and a head. So the probability for that to occur is always going to be 4 out of 125. That's 4/5, if you kind of followed along here, 4/5 times 1/5 times 1/5. And since, once again, tails are 1/5 and heads 4/5, it's always going to be that same probability for all 3 of these. So it's 4 over 125 plus 4 over 125 plus 4 over 125, which is 12 over 125. Sorry, it's getting a little messy at this point. Number 3, at least 1 tail. So that was 7 out of 8, at least 1 tail. So we're going to have to calculate all 7 of those and then add them up and see what we get. And then, actually, as I kind of thought about that a little bit more, the only one that was not included was this top one, and we already said that was 64 out of 125. So then, at that point, everything else that is left from 1, so if you subtract 1 from that, you're going to get, 61. So that means the remaining one would have a probability of 61 over 125. So I almost did a lot of work that I didn't need to do by adding up all 7 of them. Just wanting, again, thinking back to what I've already done. So saved us a little bit of time there. Number 4, exactly 2 tails. So exactly 2 tails. So once again, find the ones that have exactly 2 tails. We did that kind of closer to the end where they had the 3/8 here, where I have the check marks right now. We'll figure out what those are. And technically, we already did that one on number 2, 1 head and 2 tails. If there's exactly 2 tails, then the other one's going to be a head. So number 2 would be the same as number 4, and that would be 12 over 125. So just by paying attention to what we've already done, we saved ourselves a little bit of time on those last 2. Question 70, are the triangles below similar? If so, write a flowchart that justifies your conclusion. If not, explain how you know. So the triangles that we're looking at here would be the smaller triangle embedded in the larger triangle. So that's what we're trying to prove are similar. We see that they both have a right angle, so that's good. And the other thing is that this angle C represents both triangles. So you have the little triangle with angle C, but you also have the larger triangle with the same angle C. So therefore, angle C is congruent to angle C. So the triangles are similar by angle-angle similarity, and we're going to justify that by using a flowchart. So there is the flowchart, the 2 things that prove that the triangle are similar using angle-angle similarity. Angle B and angle E are congruent, or measures are the same because they're both right angles, and angle C is equal to angle C. And you do have to write that even though they're the same angles because they're different parts of the, it's 2 separate triangles. So therefore, we know the triangle ABC is similar to triangle DEC, and that's by angle-angle similarity. Question 71, you roll a die and it comes up a 6 3 times in a row. What is the probability of rolling a 6 on the next toss? Now, those are independent events. Every single time you roll a die, the probability is not going to change when you roll it again. Now, if we're saying, the probability of it rolling 6 4s in a row is different. This is just saying what is the probability of rolling a 6 on the next toss. So on a standard die, there are 6 sides, and so therefore that would be 1 out of 6, as long as it is a fair die. Question 72. Mr. Singer made the flowchart below about a student named Brian. And it says Brian is always late on Tuesdays. Today is Tuesday. Brian will be late today. What is wrong with Mr. Singer's flowchart? So what's wrong? Well, let's read this again. Brian is always late on Tuesdays. And then it has the arrow going to today is Tuesday. That's a problem because it implies that Brian is always late on Tuesdays and then today must be Tuesday. So that shouldn't be the order that it goes in. This does not imply that today is Tuesday. So that's what is wrong with Mr. Singer's flowchart. On B, it says rearrange the oval so the flowchart makes more sense. And so how we can fix this is to take and make two ovals with the top in terms of Brian is always late on Tuesdays. Just going to do some abbreviation here. So Brian is late on Tuesday, and then today is Tuesday. Then Brian's late on Tuesday, today is Tuesday. Then the third one is Brian will be late today. And we have arrows going from these two. So once again, Brian's late on Tuesdays, today is Tuesdays. Those are on the same level. And then you have the arrows pointing to Brian will be late today. Question 73, write the first four terms of each of the following sequences. So on part A, we have a geometric sequence. You can see that it's being multiplied. So the first four terms, A sub 1, that would be your first term. So 3 times 5, 1 minus 1. And so when we simplify that, that's 3 times 5 to the 0 power. 5 to the 0 is 1. So our first term is 3. So 3, comma. And then we could do this again, and I'm just going to show you this, that we can just plug 2 in, 4 in, and repeat this 4 times. But remember, once we know the pattern, we don't have to keep plugging in here. So this would be 3 times 5 raised to the first. 3 times 5 would be 15. The multiplier is the 5. The first term is 3. So if I just multiply by 5 each time, I don't have to go through and plug everything back in. So 3 times 5 is 15. 15 times 5 is 75. 75 times 5 is 375. And so think about that as you're going through, that you don't necessarily have to keep plugging them in once you know what's happening in, or if you know what's happening in the equation there. Part B, it's given us the first term, so we already have a starting point. And then the next thing tells us that at n plus 1, that next term, you're going to take negative 5 times the previous term. So this is telling you just what is happening in the problem, is that if I want to find the second term, then I will take the first term and multiply by negative 5. Well, if I take the first term and multiply by negative 5, then that would give me negative 50. And then I multiply the next term, negative 50 by negative 5, and I get 250, and 250 by negative 5 is negative 1,250. And so this is called a recursive formula, where you have to use the previous term to find the next term. And question 74. Find x and y in the diagram below. Show all the steps leading to your answer. Well, that's easy enough. Here's x, and here is y. So that is it. It just says find them, and I found them. So that one's done. Okay, just kidding. Let's find the value of x and y. Let's see, we got a right triangle. We know the side length is 6 here, so we can use our tangent ratio. Tangent of 60 degrees is equal to opposite side, which would be x, over your adjacent side is 6. And remember, that's a delta y over delta x. You would have to reorient the triangle, though, if you wanted to kind of see that. And then we can figure out tangent of 60 using our calculators, multiply both sides by 6. And when you do that, you will get an approximation for x. And x is approximately 10.39. It is a right triangle, so we can now use Pythagorean theorem to find the other side, or the hypotenuse, I guess. 6 squared plus 10.39 squared is equal to y squared. So this will be 36 plus 10.39 squared is 107.5. 0.9521. I'll write all the numbers. Is equal to y squared. We're going to add those two up to get 143.9521. And then we can take the square root of that number to help us get the most accurate answer that we can from the numbers that we have, and that is 11.998. So we can say y is approximately 12 on that one. It might be exact if we would have used the exact number from here. Then my guess is y probably would have been 12 exactly anyways. So it looks like we have found the value of x and y.